Okay, we're talking about multiplying and dividing rational expressions. On your warm-up, you see you have a trinomial, 1, 2, 3 terms. You remember you can do your x factor to try and get your answer to that. And then for adding fractions, you remember you need to get a common denominator. All right, moving on into the new material. For multiplying our rational expressions, we're going to multiply straight across. You know how that works for fractions. We can, before we multiply straight across, we could notice, well, there's an r on bottom, there's an r squared on top. This r can cancel with one of the exponent r's. We're just left with r. So we can reduce it first, and that'll make our numbers neater. Or we can go ahead and multiply straight across and then reduce at the end. R squared x 3t to the fourth. Normally we would put the 3 in front and put them in descending numerical order. So it would look something like 3t 4r squared x over 9t to the third r. And then we can do our reducing. This r cancels with one of the r's on top. R squared is r times r. These 3 t's cancel with 3 of those, and we're just left with 1 t on top. And then 3 divided by 9 would just be left with 3 there. So the final answer, there'd be 1 t on top and an x, and on bottom we've canceled everything but a 3. Moving on to example 2. We remember when we're dividing fractions, the left stays the same, and you flip the right side and you turn it into multiplication. KFC, keep the left, into the third, flip the right, 12 over 25 in, and change the sign. And so now it's the same as what we'd said before. We're going to multiply straight across. And as we already noted, remember we said we can reduce. Both of those can be divided by 3. This one would be left with 4. This would be left with 5. And that way when we multiply straight across, we're not doing 4 times 12. We're doing 4 times 4. And you see it makes the math a little easier. But of course, you can just multiply straight across. And since you have a calculator, it makes the math simple. 4 times 4 is 16 over 5 in to the third. 20 times 25 in, and 5 times 25 is 125 in to the third times in is in to the fourth. Alright, on this next one we're told to simplify. On the top we see that we have a squared and a, so we're going to factor out. We have a common factor. We're going to factor that a out. We're left with 3a minus 2. So we took this a and we took this a and we factored it out. If I distribute it back in, a times 3a is 3a squared, and a times negative 2 is negative 2a. So we just factored out the a, and now I can cross out. I can simplify. So the final answer there is just 3a minus 2. This next one, we want to do a similar thing. We want to be able to cancel something from the numerator and the denominator, but the way it's written, we can't do it easily. We have a trinomial on top and a binomial on bottom. So what we're going to end up doing here is factor the trinomial on top so that we get 2 binomials, and hopefully one of the 2 binomials will cancel with the binomial we have on bottom. So we can x factor, or we can do it in our head. We know that there is 20 goes on top. That's 1 times the c term. And then the b term is on bottom. And we ask what 2 numbers multiply to give 20 and add to give a negative 9. Well, one of the hints, since we know we're going to want to cancel it with this bottom one, is negative 5 will be one of our numbers. Negative 5, well, what multiplied times negative 5 would give us a positive 20? Well, how about a negative 4? And indeed, negative 5 plus negative 4 does give us a negative 9. So we have x minus 5, and x minus 4. Those were the two factors we got there, and of course the denominator is already x minus 5. So what binomial on top and bottom can be crossed out? Well, x minus 5. So we're just left with x minus 4 as the only thing left. All right, on example 5, it's telling us to divide a trinomial by a binomial. When you get into the upper level maths, you're going to end up learning how to do long division with these. X squared plus 5x plus 6, and then x plus 2 on the outside. And you will divide. You always put them in descending order, and then you divide. How many times does this go into the first term, etc., and you work your way down. We're not going to do that. You're going to use logic, thinking, well, it's x plus 2 times something would give me this trinomial. So you're thinking, what times x would give me x squared? Well, another x we'd need. And now we know, how would we get this last term? Where does the 6 come from? Well, it's 2 times whatever the last term of this other one would be. That'd give us a 3. Let's check and see if it works. X times x is x squared. Yes. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. 3 plus 2 is 5x. And so we see we have the answer that matches. So instead of doing the long division, which you'll get into next year, you're going to just be thinking backwards and asking what is that missing term that I would need to multiply to get the trinomial. Number 6 is done the same way. You can draw a rectangle and label it, but the area is x squared minus 6x minus 16, and one of the sides, or the length, is x minus 8. So the question is, what other binomial would we multiply by to get that? Well, if it's x squared, we would need an x times an x. And then how do I get this negative 16, negative 8 times what? All right, so you've got those examples. I don't want to finish that one. I want to work on one of these on the back. Let's take a look at number 8, which is just telling us the word quotient. What is the quotient? That's just saying, what are we going to multiply by this to give us this trinomial? The one I want to work on is right here. This is a peculiar one because it's a binomial and we're getting out a binomial, but this we can tell because it's a difference of squares. It's missing that middle term. So we know that it has to be the identical binomial, but it would have to be x plus 7 on this one. Why? Because we're missing that middle regular x term. So let's practice it just to see what I'm talking about. X minus 7, x times x is x squared, x times negative 7 is negative 7x, 7 times x is 7x, 7 times negative 7 is negative 49. So we see the negative 49, that matches. We see the x squared, that matches. And what happens to our middle two terms? Well, because it's a negative 7 and a positive 7, they cancel. That's why there's no middle x term there. So that's just knowledge of difference of squares and being able to recognize it. All right, good luck on the rest of this sheet.